Let's talk about Squeeze theorem or Sandwich theorem, right? What is Squeeze theorem? So since its another name is Sandwich theorem, think about a sandwich. Let's talk about a chicken sandwich. Let's say we have a two piece of bread, one bread and two bread, right? And in between them, you put one chicken, one part of chicken. You squeeze them in between them, right? Then you have lettuce and all this stuff. So now, since you see here, this is our chicken sandwich, right? Here the chicken think it's as a tricky function, and the bread is just the easy function. Okay, two easy function. So whenever we find out a tricky function, if we try to find out the limit of the tricky function and it gives us hard time, we can squeeze this tricky function in between two easy function and find out the limit at a point where both of them are same, this two easy function, and we find out the limit for the tricky functions. Let's look at the graph that will give you the proper explanation. So let's say we're gonna draw a graph. Let's say we have x and y, right? Let's say we have one function, let's say f of x, like this, right? Then let's say we have another function like this, something let's say something like this. Okay, let's say this is g of x. Now in between them we have a one tricky function, let's say h of x. You see, so in here, right, let's say the point is a, and here when we x approaching to a, we find out y is, let's say, p. So here if you see f of x when x approaching to a, it's p, right? So we can just say limit x approaching to a for f of x is just simply p, right? And the same thing with g of x, when limit x approaching to a, g of x is just simply p, because when x approaching to a, we get the p, right? Now let's say since this function h of x is between f of x and g of x, so you can just write down f of x is between h of x is between g of x, and since when x approaching to a, g of x is just simply p and f of x is just simply p, we can say when x approaching to a, limit x approaching to a, h of x is just simply p. This is our squeeze theorem. So let's do an example that will give us answer. Look at this. This is one kind of tricky function, right? Because since if you when x approaching to 0, if you plug in the 0, you get 0 sine 1 over 0, which is undefined. This is tricky, right? So instead of that, let's write down this sine function in between two easy function. We know the sine function is always between -1 to 1, right? -1 to 1. So you see sine 1 over x, any value you plug in there, you always get an answer between -1 and 1. So since we have the x, we multiply this with x. Okay, if we multiply with this x, we get -x, then we get sine 1 over x, then x, right? Now since x approaching to 0 here, right, so we can just find out here when we limit x approaching to 0, -x, you get 0. Same here, when limit x approaching to 0, x is just 0. Since both of them are 0, by squeeze theorem we can just say sorry, here should be x. When we multiply with x, we get x, right? We can say that limit x approaching to 0, x sine 1 over x is just simply 0. Since here the other two easy function has the same value, so when we squeeze x sine x over x, this function, we get the same value by the squeeze theorem, 0, right? This is the detailed explanation here. You guys can take a look at it. Now let's do another example that will clarify our view. So let's say if we have f of x is between one function 2x and x squared plus 1, then we have to find out x approaching to 1, f of x, right? One limit. So let's say we find out the limit x approaching to 1 for this function. Limit x approaching to 1, 2 of x is just gonna be simply 2 times 1 which is 2, right? And for this function, limit x approaching to 1, we have x squared plus 1. So x squared is just simply going to be 1 squared plus 1, which is 2. So you see, in both cases we get 2 and 2. So since we have it, so if we find out now limit x approaching to 1, f of x is going to be simply 2. This is our answer. If you guys have any question, write down in the comment section. Thank you.